Welcome back, guys. So today we are going to be discussing about Venn diagram. So Venn diagram is like the other part of the set. In the first class, we have dealt with the main notation of set and all. So now we are going to be dealing with a Venn diagram. So what is a Venn diagram? So a Venn diagram, in just a simple sentence, is just a diagrammatic or a pictorial representation of a set. So which means we are representing a set using a picture or a diagram. So in this case, we are going to be explaining what a Venn diagram is. So this diagram that I put down here, this rectangle and these two circles, represent a Venn diagram. So let's explain what this particularly means. In set, this rectangle here encompass the whole set. It means it is what all the other sets are present inside, which means each of these circles represents a set, and each of these sets are inside this rectangle. That means the rectangle represents the whole set, which is the universal set that we have said. So we call the universal set this symbol U, or we call it this symbol. Now let's take the first circle as A and the second circle as B. Now inside each of the space we have there, let's take this as space X, space Y, and space Z. Now, what does this mean? It means this first circle, the green circle here, is the first set A, and this blue circle here is the second set B. Now let's explain what we are going to put inside those circles. Inside those spaces where we put X, Y, and Z, what do they represent? Let's explain it in layman language before we use set notation for that. So let's take it this way. X, any elements of any set that we put in this position X. And remember that this X is present inside this circle of A that we call set A. So this X is belonging to one portion of that set A. Now, this Y is in between the blue circle and the green circle, which means they are basically set of elements that belong to both. Y, this Z are set of elements that belong to only B. X belong to only A, Y belong to both, and Z belong to only B. So I'll say X is equals elements that belongs to A only. Now Y, elements that belongs to both A and B. That is set of elements you can find inside set A and also find them inside set B. And Z are elements that belongs to B only. So let's have one more point. Let's just call this point E right here inside the rectangle. So the point E, it is not inside the first circle A nor circle B. So we're going to say elements that does not belong to either A or B. Now that's it. Now let's take all this in set notation. How are we going to represent all this in set notation? So we'll take the position one by one the way we took it. Position X, what are we going to call that? Set of elements that belong to A only. Now, in the previous notation that we said, we talked about the set and its complements. We will have a set, for example, set A. We have some elements inside set A, Then the complement of set A will be all the elements that are not present inside set A but are present inside the universal set. So basically, the position X here will represent A intersection B complement. What does this mean? A intersection B complement. Now, B complement means those elements that are present inside the universal set but not present in B. So if you have elements that are not present in B, that means those elements are basically present in A. So A intersection B complement is what this space represents. So let's put it there. A intersection B complement. And this other part here, the set B, will be A complement, which is complement of A intersection B. And in the middle here, we are going to have what? A intersection B. That is where set A and set B, what elements they have in common. Now, anything that belongs outside these two circles, that is inside this rectangle here, we are just going to say A union B complement. What does A union B complement means? A union B complement means when we combine the set of elements inside A and B. Listen, when we combine the set of elements inside A and B, like we write all the elements in A and B together, then we subtract all those elements from the universal set. Anything that remains is A union B complement, because those elements are the elements that are not present inside A union B but are present inside the universal set. So I hope that is clear. Now we move to another type of Venn diagram in a case whereby we have more than two sets. Let's just same label, but this time around we are going to be having a cumbersome solution. So because we now have three circles. So now this rectangle or square or whatever shape we call it is still the universal set. So same symbol. Now we take this as A, we take this as B, and we take this as C. Then we label the way we have done the other time. This time let's use A, B, C, D, E, F, then G. So don't let me write much this time. So A is all the elements that belong to A, B, and C. As you can see, all the three circles intersect at that particular point A, at that particular position A. So A is all elements that belong to A, belong to B, and also belong to C. That is intersection. Then what is position B? Position B represents elements that belong to A only, elements that belong to the green circle only. So what do we mean by only? If we have an event where we have the two sets of food being distributed, like rice and beans. So it is possible that we have people that are basically allergic to beans or allergic to rice. I don't think anybody is allergic to rice anyway, but let's just assume some people are allergic to rice anyway. So possibly some people are allergic to rice and some are allergic to beans. Let's just say possibly, it's just a possibility. So which means there are people that don't like to eat beans and there are people that don't like to eat rice. Meanwhile, there will be people that actually like to eat both. And there will actually be people that actually like to eat none of these two foods. So when we say people that eat rice, it doesn't mean these people do not eat beans. Some of them might actually have eaten beans, then eat rice again. But when we are counting those particular set of people that actually eat rice, we are going to count even those that ate rice and beans. So, but when we say those people that eat rice only will be particular to people that ate rice and nothing after that. So in that case, at this position B, anything we put here in this position B belong to the set A only. So I'll just call it set A only. Let me just use this notation. Um, Now, at this position C, we just say B only. Let's use that notation here. At this position D, we're going to say what? C only. Now, at this position E, we'll say, now you observe that position E is only containing, we only have green circle and red circle that intersect, which means A and B. So basically, there are elements that only contain element of set A and element of set B. So we'll say this is like A intersection B intersection C complement, of course. So D, no E, F. So the F is basically literally the same thing, A and C. So we say A intersection C intersection B complement. And G, we have B intersection C intersection A complement. And the middle, which is A, we have already done that, which is A intersection B intersection C. Then let's see how to solve our problems when we have problems on this Venn diagram. So let's look at this problem. The problem says a game master of a school called 50 students of the school to select two teams for the school in football and volleyball. 30 students could play football, while 20 students could play volleyball. If 8 students could play both games, then the question tells us to find one, the number of students that could play football but not volleyball, which means the number of students that could play football only. So the second one says the number of students that could play volleyball but not football. That means volleyball only. And the third one says the number of students that could not play any of the two games, which means students that couldn't play volleyball and that couldn't play football, which means they didn't play either of the two. So, how are we going to solve this problem? The first thing, we are following the Venn diagram here, so we're going to use Venn diagram to solve this problem. But before that, we're just going to write out the parameters we are given. So firstly, the question gave us the universal set here to be 50, which means total number of students that we are considering. The second says the number 30 students could play football, which means number of students, that is the cardinality of students that could play football, is equals to 30. And 20 students could play volleyball. I will say number of volleyball is equals to 20. And next, we'll have a student could play both games, which means number of football intersection volleyball. So which is what? 8. And there is a certain number of students that couldn't play any, but we don't care about that for now. So let's have the Venn diagram for this. So the Venn diagram will have a rectangle. Then since we only have two instances, the volleyball and the football, we are just going to have two circles. So now considering these two circles, the first one I'm going to label this as number of football. Okay, let's change that. So number of football. So this is going to be 30. And the second one is number of volleyball. This is going to be 20. And here, this is the universal set, which is 50. And the first thing you should label is the intersections. So I have 8 as intersection of the football and volleyball. So I'll put 8 in the middle here. So this 8 means that a part of this circle that belongs to football is already this 8. And a part of this circle that is for volleyball is also 8. So now what I will have inside this place here is number of football minus 8, which means total number of students that play football is 30, but minus those that play football and volleyball. So we give us those that play football only. So and inside here too, I'll have number of volleyball minus 20 minus 8 rather. So which means I have 30 here. 30 minus 8 will give me 22, right? And here I'll have 20 minus 8, that will give me 20 minus 8, that will give me 12. So I have 12 here. So now the first question says number of students that could play football but not volleyball. So those that could play football but not volleyball are those that are inside the circle of football alone. So Roman figure 1. So will be number of students that plays football only, which means but not volleyball. This will be equals to 22. Now next, Roman figure 2, number of students that plays volleyball only. So this is going to be 12. And the last question says the number of students that could not play any of the two games, which means let those people that play none of the two games, let's just call them X. So we're going to put X outside here, which means they don't belong to either the circle of football or the circle of volleyball. So I'll call them X outside here. So to calculate that, if we add all of this together, they have to give us 50 because the universal set is 50. So I'm going to say 50 must be equals to X plus 22 plus 8 plus 12. So which means 50 must be equals to X plus 22 plus 8 will give me 30, and 30 plus 12 will give me 42. So I'm going to have plus 42 right here. So I'll have X equals 50 minus 42, which will give me 8, which means those students that play none of the two games, they are 8 in number. So that is the first question that we have here. So let's see another problem. So in this problem, the question says in an examination, 18 candidates pass mathematics. So I'll start by saying number of candidates that pass mathematics is n of m. So this is 18. Then next, 17 candidates passed physics, which means number of p, which is for physics, is equals to 17. Then 11 candidates passed both subjects. So I have number of mathematics intersection physics is equals to 11. And one candidate failed both subjects. So I'll say number of mathematics intersection physics complement. That means failed, the opposite. So is equals to 1. So now we're going to just draw Venn diagram for this problem first. So I have this here. So the first circle, then the second circle. Then let me use another color for this. So now the number of mathematics equals 18 and the number of physics equals 17 and the number of both equals 11, which means here we are going to say 18 minus 11. So we'll say 18 minus 11 here, which will give us 7. So and here we're going to say 17 minus 11, which will give us 6. So and those that fail will be outside the circle here, so which I'll have 1 here. Then let's answer the question. The first question say 1, the number of candidates that pass mathematics only. So I'll say number of mathematics only is equals to, so those that are present inside the mathematics circle only, so that is 7. And 2 says the number of candidates that pass physics only, so pretty much the same. So I have P only, so this is 6. And the total number of candidates that sat for the examination, so here we are looking for the universal set. So to do that, we are going to say the universal set, which is the number of candidates sat for the whole of the examination, is just the addition of all of this. So I'll have 1 which fail plus 7 math only plus 11 plus 6. And when I add all this, I'm going to have around 25. So I have 25 candidates. So this is how to solve this problem. You can pretty much try it by yourself again. So let's see another problem that we have here. This is another problem here. The problem is in a party for 30 young children. So 30 young children, that is all our consideration here. So we're going to say universal set is 30. So 12 were served with Coca-Cola drink. So I'm just going to take Coca-Cola as a C. So I'll say number of Coca-Cola drink is 12. And 14 were served with Pepsi Cola. So I'm just going to take Pepsi Cola to be P. And this is 14. So if 9 children were served with Coca-Cola but not with Pepsi Cola, which means number of those that are served with Coca-Cola only but not with Pepsi Cola, so that means is 9. So this says we should find, so let's just draw the Venn diagram for this problem right here. So let's go back to this page and just take the Venn diagram from there. So I'll just clean out all of this. So let's have this. So which means the universal set in this case is 30. So and I have number of C right here to be 12. Then I have number of P, Pepsi Cola is 14. I don't have what is in the middle, but I'm sure I have number of C only. If I have number of C only, that is 9 right here. And if I have 9 right here, I can pretty much subtract this 12, this 9 from 12, and that will give me 3. So that means 3 will be in the middle here. So that's it. So and if I subtract this 3 from this 14, I'm going to be having 11. So 11 will be right here. Now, if we add this up, 9 plus 3, we'll have 12. 12 plus 11, that gives us around 23. And 23 is not totally in 30, which means 30 minus that 23 is 7. Means 7 does not drink anything. So the first question said the number of children that were served with both drink, and that is what we have in the middle here, the intersection. So number of, that means the first question says we're looking for number of children that are served with C intersection P, and that is 3. And 2 says the number of children served with at least one type of drink. So I'll say number of at least a drink. At least means from that number mentioned upward. So meaning those that are served with one or those that are served with both. So we are going to say 9 served with Coca-Cola only plus 11 served with Pepsi Cola only plus 3 served with both. So this result into 23. So this is it. And the third question here says the number of children not served with any of the drink, which means number of Coca-Cola intersection Pepsi Cola complement, and this will be 7. Then let's have this problem right here. This is more than the one we have been doing. This kind of pretty much all 50 science students in government college in Ibadakra were asked their subject combination. So we have in check 50 science students. So our universal set is 50. So 18 of the students offer further mathematics. So I'm going to take further mathematics as F. So I'll say number of F is equals 18. So and 21 offered chemistry. So I'll say number of chemistry C equals 21. And 16 offered biology. I have number of biology B is equals to 16. Then 7 students offered further mathematics and chemistry. So I will say number of further mathematics intersection chemistry is equals 7. Also, 8 students offered further mathematics and biology. So I'll say number of further mathematics intersection biology is equals to 8. And 9 students offered chemistry and biology. I'll say number of chemistry intersection biology is equals to 9. And lastly, say 5 students offered the 3 subject combinations, which means number of further mathematics intersection chemistry intersection biology is equals 5. So using Venn diagram, so let's draw a Venn diagram for this problem first. So since we have three things we are considering here, so we are going to be having 3 circles in our Venn diagram. So for it to be clear, let's just use a different color for this for the circle in this Venn diagram. So here I have this first circle right here, and I have the second. Is that good? That's not good. And I have the third circle right here. So this is it. So the first one, I'll call this number of further mathematics, and I'll call this number of chemistry, and I'll call this number of biology. So let's check the number out. So universal set is 50. I'm just going to put it up here. Universal set equals 50. Then here I have number of further mass is 18. So this is 18 here. And let's go back here. This is 21 and 16. So I have chemistry 21 and biology 16. Then the next is number of the 3 intersections. So I have 5 right here. So this is going to be 5 in the middle here. Then if 5 is in the middle, then the next, the two intersections, we have further mathematics intersection chemistry to be 7. Now we'll come here. Further mathematics intersection chemistry is 7. What does this 7 mean? This 7 means all this portion of this right here, which include that 5. So which means 7 include this 5. So since we are not labeling that 5, since we have already put that 5 in the center, so we want to label only this place. So we have to subtract that 5 from that 7. So that will give us what? 2. So here we'll have 7 minus 5. That will be 2. So I'll just circle this right there. So we go back to further mathematics intersection biology, which is 8. So further mathematics intersection biology right here is 8. So we're going to subtract this 5. So that will give us 3. So the next we're going to have chemistry intersection biology 9. So here we subtract 5. That will give us 4. Then to get what is here, we'll add all this together and subtract it from this 18 here. So I have 2 plus 5, that will be 7, plus 3, that is 10. 18 minus 10 will give us 8. So 8 will be here. So to get this two, we'll say 5 minus 3, 5 plus 3, that is 8. 8 plus 4, that is 12. And 12, 16 minus 12 will give us 4 here. And here as well, I have 2 plus 5, 7. 7 plus 4, that is 13. No, 7 plus 4 is 11, right? Sorry. So then when we subtract 11 from 21, that will give us 10. So this is the Venn diagram here. It means when we add everything inside the circle, we have to get 50. And if we don't get 50, it means there are some students that did not offer any of the combinations. So let's try that. We have 8 plus 2, 10, plus 10, 20, plus 5, 25, plus 3, 28, plus 4, 32, plus 4. That's 36. When we subtract that from 50, that will give us 14, which means there are 14 students that offer none of the 3 subjects. So let's go back to the question and answer them. The first question said the number of students that offered further mathematics, but offered neither chemistry nor biology, which means further mathematics only. So I'm going to say first one is number of F only. So and that is 8, which is what is in this circle alone. 2, we have the number of students that offered chemistry but offered neither further mathematics nor biology, that is chemistry only as well. So chemistry only here is 10. So I have number of C only. This will give us 10. And the third one, I'm going to have number of biology only, maybe. So that is 4. Let me just answer that before I look at the question. Then who did not offer? Okay, the third one is that. So the number of students who did not offer any of the 3 subject combinations, and that's what we just calculated outside here. So which means number of further mathematics intersection, chemistry intersection, biology complement, and that will be 14. So we are done with this question. Thank you.